Welcome back to the AWS Machine Learning exam walkthrough. So this time we're going to go on XGBoost. But before we get started, hit this like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So XGBoost, this is the champion of structured data machine learning. So in the world of machine learning algorithms, which is competitive, few have achieved the legendary status of XGBoost. Standing for extreme gradient boosting, this algorithm has dominated Kaggle competitions. It's powered countless production systems and earned a reputation as the go-to solution for structured data problems. Its secret lies not in revolutionary new concepts, but in the masterful combination of proven techniques executed with exceptional engineering precision. So XGBoost builds on the fundamental concept of decision trees, but transforms them through an ensemble approach that creates something far more powerful than the sum of its parts. Each tree in the sequence learns from the mistakes of its predecessors, gradually correcting errors and improving predictions through a process called gradient boosting. So this iterative refinement, combined with advanced optimization techniques, enables XGBoost to achieve remarkable accuracy across diverse problem domains. So the evolution. All right. So traditional decision trees make predictions by following a series of if-then rules, branching through data features until reaching a final decision. While intuitive and interpretable, individual trees often overfit to training data, performing poorly on new examples. XGBoost addresses this through limitations with ensemble learning. So it combines many weak decision trees into a single strong predictor. So this algorithm boosts strategies that operate sequentially rather than in parallel. Each new tree focuses on specifically correcting the errors made by the previous ensemble, using gradient descent optimization to minimize loss at each iteration. So this approach lets XGBoost reduce both bias and variance, achieving superior performance compared to standalone trees or even parallel ensemble methods like random forest. What makes XGBoost extreme is its engineering sophistication. So this algorithm incorporates advanced regularization techniques to prevent overfitting, handles missing values automatically, supports both regression and classification tasks, and scales efficiently across multiple processing cores and machines. So these operations and optimizations transform gradient boosting from an academic concept into a production-ready powerhouse. Okay, so open source meets the cloud. SageMaker offers XGBoost through two distinct approaches, reflecting the algorithm's evolution within the AWS ecosystem. Originally, AWS simply wrapped the popular open source XGBoost implementation, providing the algorithm as is within SageMaker's managed infrastructure. Over time, AWS enhanced the foundation with cloud-native app optimizations. The built-in algorithm provides a fully managed experience with optimized containers, distributed training support, and seamless integration with SageMaker's broader machine learning workflow. This framework preserves compatibility with the standard open source XGBoost Python package, enabling teams to migrate existing code while leveraging SageMaker's infrastructure benefits. This dual approach offers strategic flexibility where teams can start with a framework mode for maximum compatibility, then migrate to the built-in algorithm as they mature their machine learning practices. And you can see deeper AWS integration. So both modes support the core XGBoost functionality while differing in their operational characteristics and optimization focus. The input format supports reflect this evolution. Initially limited to CSV and lib SVM formats, XGBoost now accepts record IO, protobuf, and Parquet files, providing better performance for large-scale data processing. So this expanded compatibility enables seamless integration with modern data pipelines that emphasizes efficiency and scalability. So how does this apply? Oh no. That was not the one I wanted. That's okay. Let's try this. Okay. So how does this scale across industries, right? So XGBoost's versatility makes it applicable across virtually every industry that works with structured data. So financial services can use its classification capabilities for fraud detection, where the algorithm's ability to handle complex feature interactions helps identify sophisticated fraud patterns that simple models might miss. E-commerce platforms can use XGBoost for recommendation systems and price predictions, taking advantage of its regression capabilities to model complex relationships between product features, market conditions, and customer behavior. The algorithm's efficiency enables real-time inference at the scale required by modern digital platforms. Manufacturing organizations can use it for predictive maintenance and quality control, where its robustness to noisy sensor data and ability to capture nonlinear relationships can prove invaluable. So the algorithm can learn complex patterns from historical equipment data to predict failures before they occur. And then healthcare applications can use this for risk stratification and treatment optimization, where the algorithm's interpretability features can help clinicians understand model decisions while maintaining high predictive accuracy for patient outcomes. All right, we're going to try a little hands-on. All right. Let's go. All right, this is one of the more recently used ones. Let's go over here. Here we go. So we're in SageMaker AI. Go to training. Go to training jobs. Create a training job. Let's call it XGBoost. XG test. All right. Okay, so this will identify for the business purposes. This is naming conventions are always important when it comes to cloud. All right. So in here we can go algorithms. We use the built-in. Built-in XGBoost is the first one. All right. And we can, let's see, use the built-in. Oh, forgot the IAM role. Oof, that's important. Oof, that's important. Okay, so the IAM execution role ensures appropriate permissions for S3 access, right? And this is for S3, CloudWatch, and any other AWS services your workflow requires. So the role has to have read access to your training data bucket and write access to the model output location. Remember that get object, put object, that's a portion of it. You can create a new role. You can use one you already have. It's up to you, all right? So we selected that. All right. And we have all this training, the metrics. All right. And then we scroll down a little bit. We get our instance type. So we'll do the ML4. Yeah, that's fine. MLM4. That's standard. That's standard. Let's see. Keep alive period. Let's do 5 days. Encryption. You usually want to have encryption. Data at rest, data in transit. Maximum runtime, 5 hours. All right. Network isolation. Yeah, let's use the default, right? For those containers. All right, and then you want to do the hyperparameters. Okay, so let's see. First, we want to see objective. All right, so objective. So you have a couple of different types right here, right? So binary is for um, binary classification, right? Then you have like the multis, which are good for multi-class classification. And you have the regs, which are good for regression tasks, right? So these are the fundamental ones, right? And these determine like loss function and evaluation metrics that XGBoost will employ throughout the training. All right, so let's do squared. We'll do reg squared area. All right, squared error. Excuse me. We do num round. Okay, so num round is here to control the number of boosting iterations. So start with moderate values like 100, and then you could increase this based on convergence behavior and validation performance, right? So more rounds enable learning complex patterns, but increase overfitting risk and training time. So do, oops, I was not meant to hit 200, excuse me. Let's see, we want to go. I wish these were a little darker. It's harder to see. Oh, wow, it's not there. Okay, ETA. Okay. So eta, this is the learning rate, right? So you balance training speed and model quality. So lower values on that 0 to 1 scale. So 0.1 provides more stable training, but requires more iterations. Higher values like 0.3, 0.8, whatever, accelerates convergence, but risks overshooting optimal parameters, right? So the learning rate often requires adjustment based on the data set characteristics and time constraints. All right, so 0.3 is good. Max depth. Okay. So max depth, oops, excuse me. So max depth, this controls the individual tree complexity. So values between 3 and 8 on like a 1 to 10 scale works best for most problems. So deeper trees capture more complex patterns, but increase overfitting risks. So monitor the validation performance to find the optimal depth for your specific data sets. Then subsample. All right. So subsample, so this introduces randomness that improves generalization. Values like 0.8 mean each tree trains on 80% of the available data. So that 0 to 1 scale, right? So you need to reduce overfitting while maintaining learning effectiveness. So this works synergistically with other regularization techniques. So let's say 0.7. All right. 0.7. Okay. Gamma. All right. So gamma controls the minimum loss reduction required for tree splits. So higher values make the algorithm more conservative, preventing splits that don't meaningfully improve predictions. Right. So this prevents, this helps control model complexity and training time. All right. So let's do 0.35. All right. And then you have, let me see, lambda and alpha, right? So these help to prevent overfitting through different mechanisms, right? So lambda, or I'm sorry, alpha is regularization that encourages feature selection by driving coefficients to 0. And then lambda regularization, this smooths coefficient values for better generalization. And then scale, pause, weight. All right. So this adjust this to the relative importance of the positive and negative classes. So common approach sets this to the ratio of negative to positive samples. All right. Of positive samples. All right. So this helps the algorithm learn from minority classes effectively. And then you have tree method. All right. Tree method. Okay. Just drop down. So you can go auto, exact, approximate, history, GPU history, right? So use GPU history when you're using GPU instances. So this single parameter can change dramatically and reduce training time for large data sets while maintaining identical model accuracy. And then I think the last one I want to talk about, let me see if I can find it. Gosh, I wish these were darker. Oh, I am not seeing it. Oh, did they remove it? It's another GPU one. I guess they removed it. Wow. Okay. All right. It might have been moved to another model. Okay. That's regardless. We'll keep moving. Okay. So when you launch this training job, you monitor the progress through SageMaker console and CloudWatch. The training will vary significantly based on the data set size, the model complexity, and the instance type, which we've walked over a little bit here. This can be minutes to hours if it's enterprise level. And the console will provide those real-time data updates on training status. We're not going to create this because it's going to cost money, and we don't want to spend money right now. At least not for training and walkthroughs. So, and then remember, CloudWatch logs will give you some insights into the training process, including like the per iteration loss values, evaluation metrics, and any warnings or errors during training. And upon completion, XGBoost will save the model artifact that's specified S3 output, which we didn't set, but you can set the output to an S3 bucket, right? And this will create artifacts that contain not only the train model parameters, but also metadata about feature importance, training metrics, and configuration settings necessary for deployment, right? So that's how you get to deploy this and create a deployment strategy, right? And that's how you get business use cases. And you can deploy the train model using SageMaker's endpoints for real-time inference or batch jobs for offline prediction scenarios. All right. Okay, so we'll go into a couple of, let's close out some of this stuff. We went over the algorithm, a little bit of how it works. We went over that with the gradient boost. We went over SageMaker AI. Um, we went over the hyperparameters. We went over a little bit about performance and models. List resources here. We went over deployment. So I guess we did. All right, let's go into some advanced pieces. All right, so XGBoost capabilities is a significant advancement in training efficiency, particularly for large data sets where traditional CPU training becomes time prohibitive. So the GPU acceleration can leverage parallel processing to reduce training time dramatically while maintaining identical model accuracy. Then you have single instance GPU training, which has been available since XGBoost's earlier versions, maybe 1.1, something like that. So it gives you like immediate performance benefits with minimal configuration changes. And you can simply set like a tree method to that GPU history that activates that GPU optimization. So that can reduce training time fivefold, right? Compared to like a CPU implementation. And then distributed GPU training, which has been introduced since version 1.5, extends it to multi-instance scenarios where a dataset size or complexity can demand additional computational resources. So this can require careful configuration and data distribution and cluster communication, but can achieve massive scalability for an enterprise workload. So the choice between CPU and GPU depends on dataset characteristics, your time constraints, your cost considerations, all those different things. And small to medium datasets often perform adequately on CPU instances with lower hourly costs, while large data sets or time-sensitive applications really benefit from GPU acceleration despite the higher instance costs. So know your use case, know what you're willing to spend, which is next portion, costs. All right. So this is not going to be, all right. So you have to make strategic cost optimizations and you don't really want to sacrifice model quality. All right. The algorithm has a memory bound nature on CPU instances, which suggests that it prioritizes memory optimized instances like M5 over compute optimized alternatives that provide unused CPU. So training cost optimization really involves balancing the instance type with the training duration. It's basically on demand. The more powerful instances complete training faster but cost more per hour, while smaller instances require longer training but cost less per hour. The optimal choice depends on your specific data set size and time requirements. So use spot instances for non-urgent training workloads to achieve substantial costs. We've talked about that a number of times. And so the jobs can typically, for XGBoost, can tolerate interruptions since model artifacts are saved periodically. So you can make spot instances viable for a lot of production scenarios. And then consider the total cost of ownership, including both the training and inference costs. While GPU training might cost more initially, the resulting models often achieve and perform much better with the same inference infrastructure, and it reduces that long-term deployment costs. All right, so production and MLOps integration. All right, so XGBoost's robustness and scalability make it well suited for production machine learning systems. But successful deployments require attention to operational excellence practices. So that means model monitoring becomes crucial for detecting performance degradation over time as data distributions shift or business conditions change. Then you have to implement comprehensive logging and metrics for both training and inference workflows. You have to monitor key performance indicators, KPIs, like your prediction latency, your throughput, your accuracy metrics, and then your feature drift to maintain system reliability and model effectiveness. So consider implementing automated retraining pipelines that trigger when model performance degrades below acceptable thresholds or when sufficient new training data becomes available. XGBoost training efficiency makes frequent retraining feasible for maintaining model freshness. I'd say XGBoost, it probably represents the most successful evolution of ensemble learning techniques for modern cloud environments. So it combines a proven algorithmic foundation with a sophisticated engineering optimization. So it gives you an organization with a powerful, reliable tool that lets you extract value from structured data. And it gives you a balance of performance, interpretability, and operational efficiency to become a component of any essential machine learning strategy, whether that's rapid prototyping or enterprise grade productions. So that's all we have for XGBoost. But before you go, hit the like button, subscribe, share this with anyone you know taking the AWS machine learning exam. But thank you and have a nice day.